All right, today we are starting our rational numbers unit, and we are looking at prime factorization, which in our book is lesson 4-1. And our learning targets today say I can identify numbers as prime or composite. I can use prime factorization to determine the factors of whole numbers. And I can express a whole number as a product of prime factors with exponents. All right, so we have some vocab to look at here. We are looking at prime numbers and composite numbers, which you might have some background on already, some background knowledge. A prime number is a whole number greater than 1 that has exactly 2 factors, 1 and itself. Okay, so if we look at some examples here, these are our whole numbers, these are our factors. Now our factors are going to be our numbers that are multiplied together to get those whole numbers. So here are some examples of prime numbers: 2, 3, 5, 7. 2 is prime because the factors, the numbers that multiply together to get 2, there's only 1 and 2, so 1 and itself. Now composite numbers, those are whole numbers that are greater than 1 that have more than 2 factors. So here are some examples: 4, 6, 8, 9, 10. So for example, 8, we could multiply 1 and 8 together. We can multiply 4 and 2 together. So it has more factors than just 1 in itself. Now, the numbers 0 and 1, they are neither prime nor composite. 0 has many factors because you can take 0 times any number and you are going to get 0 back. Okay, so it has a lot of factors. And 1 is not prime nor composite because its only factor is 1. Okay, now we're going to try some examples here to determine whether each number is prime or composite. So our first example here is 17. So we have to start with listing the factors of 17. Well, I know that 1 and 17 can multiply together to equal 17. And now let's keep going. Well, 2 doesn't go into 17 because it's not even. 3 does not. 4 does not. 5 does not go into 17. 6 does not. 7 does not, 8 does not, 9 does not, 10 does not. So now we've gone over halfway, so that tells us that there are no other factors. So since 1 and itself are the only factors that go into 17, that makes it prime. Okay, now our next one, 12, well, 1 and 12. So we're going to write out all the factors here. I know 2 goes into 12. And it goes in there 6 times. I know 3 does, and it goes in there 4 times. 5 does not. We've got 6. 7 does not. 8 does not. 9 does not. 10 and 11 do not. Now, all of the factors, there's more than 1 in itself, so that makes this composite. Okay. Now, there are a few here for you to try on your own, so pause me, and then we'll come back and go through them together. All right, 11. Let's list the factors that go into 11. Well, 1 and 11, and then let's think. 2 does not, 3 does not, 4 does not, 5, 6, 7, 8, 9, 10, they do not. So that makes this a prime number because, again, 1 and itself are the only numbers that go into it, making it prime. 15. Well, I know 1 goes in there, and it goes in there 15 times. It's not even, so 2 cannot. 3 goes in there 5 times. 4 does not. 5 does. We got 5 already. 6 does not. 7, no. 8, no. 9, no. We're over halfway. Now, there's more numbers that go into it than just 1 in itself, therefore making it composite. Yep. And 24. Well, 1 and 24. 2 goes in there 12 times. 3 goes in there 8 times. 4 goes in there 6 times. 7 does not. We already got 8. 9 does not. 10, no. 11, and we already got 12, which is halfway, so that is all of them. Well, there's more than just one in itself, making this a composite number. Okay, so now we are looking at the prime factorization, which that prime tells us that we are breaking it into prime numbers here. Every composite number can be written as a product of prime numbers. This product is the prime factorization of the number, and we are using these factor trees in order to do that. Okay, so we are taking, here's an example, we are taking 60, and we are breaking it down until all we have is prime numbers left. Okay, so for example, 60, you can break it up into 6 times 10, and then you keep going until you get those prime numbers at the bottom. Now, notice how these two trees they are different, okay? But either way, the factors are the same, just maybe in a different order. So when you look down at the bottom here, they are the same thing, okay? So then the prime factorization of 60, either way that you break it down, either way you go through the factor tree, you'll get 2 times 2 times 3 times 5, and then we can write that with exponents. So this 2 times 2, we can write it as 2 squared times 3 times 5. Okay, so there are 2 different ways that we're going to look at here to do the prime factorization of 24. The first one is the factor trees, like what we had up above. So I'm going to write down my 24. Now I am breaking this up. I'm going to just zoom in a little here. I'm breaking this up into numbers. I'm going to start with dividing this in half. So 2 and 12, because 2 times 12 equals 24. Now I know 2 is prime, so what I'm going to do, because we're trying to get to all those prime numbers, I'm going to go ahead and circle it, which tells me that we are all done with that. Now the 12 is a composite number, so we have to keep breaking it up. Again, I'm going to break it in half. 2 times 6 is 12. Again, 2 is a prime number. I'm going to give that a circle. And my 6, I'm going to break that up into 2 times 3. Now both of those are prime, so I circle those. Okay. Okay, now all of these numbers that I have circled, I'm going to write them out, multiplying them together, just like this example up here showed. And I'm going to write it at the top here, 2 times 2 times 2 times 3. Okay, now I can write these 2's with exponents. Now it's 2 times 2 times 2, which is 2 3 times, so to the power of 3 times 3. And that is the prime factorization of 24 using the factor tree. All right, the other method that you can do is divide by prime numbers, okay? So I'm going to start with my 24. Okay, I'm going to write my division box upside down for this, just to show each division step. Because what we are doing is we are dividing this 24 by the smallest prime number that will go into it. Okay, and we know that the smallest one for that is 2, and 24 divided by 2 is 12. Okay. Now we divide that again. Well, the smallest prime number that goes into there is 2. 12 divided by 2 is 6. Okay, I can divide that again by 2. Well, 6 divided by 2 is 3. The smallest prime number that goes into 3 is 3. And 3 divided by 3 is 1. So that's where we stop, okay? And now if you look at these numbers here, those are going to be all of our prime numbers for our prime factorization. So again, we can write it out 2 times 2 times 2 times 3, or 2 to the power of 3 times 3. So whichever method you would like to do, notice either way, you will get the same answer, okay? We have some examples here. You can try these on your own, and then we'll come back and do them together. Okay, the first one, 18, I'm going to do a do the factor tree for this one, breaking it up into prime numbers. I'm going to start with 2 and 9. 2 times 9 is 18. 2 is a prime number, so I'm going to give that a circle. Breaking up the 9, well, we could do 3 and 3. Both of those are prime. So we write 2 times 3 times 3. or 2 times 3 squared. And you can always go back and check by multiplying these together and see if you get your original answer back. And 2 times 3 is 6, times 3 equals 18, so it does check out. Okay. 28, I'm going to do the division method. So I'm going to start by dividing it by 2. 28 divided by 2 is 14. Again, I'm dividing the smallest prime numbers. 14, again, we can divide by 2, which is 7. The smallest prime number that goes into 7 is 7. 7 divided by 7 is 1, so that's where we stop. So we have 2 times 7, or 2 squared times 7. Okay? And our last one here, 16, I'm going to do a factor tree for this one. I'm going to start by dividing it by 2 and 8. 2 is prime. Now 8, I can divide it into 2 and 4. 2 is prime. And the 4 can be split up into 2 and 2. And I can write that out as 2 times 2 times 2 times 2, all of them in prime numbers, or 2 to the power of 4. Okay, so now hopefully you feel good about prime factorization, whether it be with a factor tree or the division method. Now we're going to look at factoring an algebraic expression, so when there's both letters and numbers. So we're doing 6ab, and we have to factor this into prime numbers. Okay? Well, if we look at the a and b, we don't have numbers for those. Okay? Those are just our variables that we have in there. So those are already factored. Those are done. So we just have to look at this 6, which we could break into 2 times 3, and we're still timesing it by a and by b. 2 is prime, 3 is prime. Our a and b are done. So our final answer would be 2 times 3 times a times b. And again, to check, we can multiply all these together. 2 times 3 is 6, times a times b would just be equal to 6ab. So it does check out. Okay, but here is our prime factorization of this algebraic expression. Okay, here's one for you to try, 18xy. Pause if you need to, otherwise we'll keep going here. 18xy, well, we're going to break this up. I'm going to break up the, okay, so I'm breaking this up into 2 and 9, and we've got our xy on there still. Okay, 2 is prime. I can break up my 9 into 3 and 3, and again our x and our y. 3 and 3 are prime. So our prime factorization for this would be 2 times 3 times 3 times x. Oops. Sorry, that's our times y times x. Okay, so this might be where a dot would be a good idea, because we are using the variable x, so it gets kind of confusing. But we could write this as 2 times 3 squared times y times x. Alright, so make sure that you bring your notes to class tomorrow with any questions that you might have. Go ahead and try the Naiku for this one. Don't forget that you can always go back and re-watch this video. You can read the examples in the book, or you could watch the personal tutor videos in the resources if you are still confused.